In SQL Server, we have a command that is very specific to this SQL flavor, because SQL has different flavors. There exists PostgreSQL, Redshift SQL, Microsoft, SQL Server flavor. So this engine has a command that is called top5. In Redshift SQL, it would be limit, and you specify the number, but in here we will use select top 5 employees. So, and we're gonna get their first name. Let's just name the table over here from employees, order by salary, not descendant order. Select top 5, first name, last name, and salary. So just give me the top 5, and here they are, 2, 4, 5, from top to bottom. Now we're gonna work with an inner join, okay? So with an inner join, we're gonna get the employees with their job title and department. But before we move on into joins, I'm gonna explain it to you visually so you can have a better understanding of how joins work, because there are different joins, and depending on what you need to retrieve from the result set, you will need to choose either one. So let me show it to you visually. Okay, very good. So in this image that you see right now, we have 4 different joins. However, there exist some more joins than these ones. We have the self join and the cross join, but let's just review the 4 basic ones. For example, a join works by matching rows from 2 tables using a related column, usually a foreign key in one table that references a primary key in another one. For example, the inner join, which is the one in the middle we have here, this returns only the rows where there is a match in both tables. For example, if we join employees with departments, we'll only see employees who are assigned to a valid department. With the left outer join right here, this returns all rows from the left table and matches from the right if they exist. So if we left join employees with departments, we'll see every employee, even those without a department. Their department fields will just show null. With the right join or right outer join, this is the opposite. It returns all rows from the right table and matches from the left if they exist. So if we right join departments with employees, we'll see every department, even those with no employees. With a full join or full outer join, this combines both tables. You will get all rows from both tables, match where possible, and unmatched rows filled with nulls. It's useful when you want a complete comparison. And then we have the cross join. So that one is special. It will return every possible combination of rows between 2 tables. It's rarely used in practice, but can be handy for generating this data. And we have the self join. This is when a table joins to itself. In our human resources database, employees has a manager ID that points back to the employee ID. A self join lets us list each employee alongside their manager, building the reporting hierarchy. Pretty much. All right, let's move on into now creating our join query. By the way, when you don't specify inner join in the join command or in the join statement, by default it'll be an inner join. So if you don't specify inner join, the engine is gonna know it is an inner join by default. Okay, so now we're gonna perform an inner join. We can actually use joins to join not only 2 tables, but we can join, those 2 tables, and out of the result set, we can join it with another table to get a new result set. I'm gonna show it to you here. So we are gonna work with the jobs table and the departments table. these two tables together and actually the employees table. So we're gonna do a join using three tables. If you take a look, for example, here, we're gonna do a select everything from the employees table. We're gonna select everything from, let me just copy this and paste it here. We're gonna get the jobs table also, and we're gonna get the departments table. Let's see what this has. So here we have, so you can see that this is the employees table, and then here we have, let me just make this bigger. So here we have the employees table, the jobs table over here, and the departments table. These three tables. So we need to join these two first, employees with jobs, and out of that we're gonna join it with the departments table, this one that is over here. Okay, and we're gonna find the employees with their job title and department. So if you see, the employees table does not have the job title that each employee has. That column does not exist in the employees table. That's why we need to join it with this one. And the employees table does not have either the department name, which is this one over here, as you can see. So what we want to get is the employee table, the job title, and the department name. So joining these two first, and out of that result set, now that we have, you know, the employee data with the job title already included, we will join it with the department table. That's the purpose of this triple inner join that we are trying to perform, so that you can see it. Okay, let me just erase this then, and let's write our query. So we're gonna select, let's just invoke, let's say, our tables from, we're gonna work with the employees table. We're gonna give an alias to this table. We actually do use aliases when we are actually working with multiple tables in our query. This helps us avoid ambiguity whenever, you know, the same name exists in both tables for a specific column. For example, we have the column name existing in one table and the column name existing in the other one. So that's why we need to reference which column we are calling out and from which table by using the alias. For example, here, employees, the employees table would be the letter E. And we're gonna work as well with an inner join. We're gonna join it with the jobs table, and this would be J. We're gonna join employees table with the jobs table on E.jobID equals J.jobID, because this column exists in both tables. We're also gonna work with another inner join. So out of this first join it with the new with the third table, which is gonna be departments, and we're gonna call this one D on E.department ID equals D.department ID. Now we're gonna pick up our columns out of this result set. It's gonna be out of this command, I mean, select E.first name, E.last name, J.job title. So what are we doing here? We're getting first name out of the employees table, last name out of the employees table, job title that is coming from inner join from the jobs table, and we're gonna get a column out of the third table, which is department. So D.department name. which is right there. Let me see. Here, I misspelled it, it's job ID. And perfect. So that's our query. We're gonna run this. And there we have it. Now we have first name, last name. These two come from the employees table. Job title comes from the jobs table, and department name comes from the departments table. So this is how we perform an inner join, and we're just getting existing matches in the employees table and the jobs table. So that's what we are getting. That's why we're getting this result set. Okay, very good. I'm gonna explain to you real quick a left join. So we're gonna get the existing matches from the left table, and if in the right table there are no matches, that's gonna return as null. So we're gonna get all employees, including those with no performance review. Okay, so we're getting the first name, last name, and we're gonna get well, actually, let's erase this and let's erase this. We're working with the employees table as E. We're gonna do a left join. We're gonna do performance reviews as PR on E.employee ID equals PR.employee ID. And we're gonna get first name, last name, PR that comes from the performance review table. We're getting the score, we're getting PR dot the review date, and that's gonna be it. Let's run it, and there it is. So as I mentioned, we're getting null values because on the right table these values do not exist. So but as you can see, we're preserving all rows existing on the left table. So we're getting all employees that are found in the left table, regardless if they do have a score and a review date in the right table, which is the performance reviews table. So this is very useful whenever you're working with with employee IDs, for example, and you need to get a report out of all employees, because that's the main table you're working with, and you're associating that table to, I don't know, to let's say a metric or a score that they might have. So because you can work with tenure employees, and then you have new hires. Those new hires might not have a score yet, but you still want to include them in a report. So that's when you would use a left join instead of an inner join, because you want to preserve all employees regardless if they do have information on the right table. So that's what happened over here.